Hi, it's Miss House. I want to speak with you briefly about the difference between average rate of change and instantaneous rate of change. The average rate of change is the slope of this line between any 2 points on the curve. So here's a point, this black dot, and here's another point, the red dot, and anytime I move this, you can see a line that's through those 2 points, and that's the average rate of change between this first point and this second point. However, the instantaneous rate of change would occur if these 2 points are at the same place. So if I move the second point back toward the first point, I get a tangent line at exactly 1 point, and that's how the curve is changing at this exact 1 point. So what I have done is I have moved that red point, this second point, back to where this point, first point occurs. So let's say that I've got these 2 points, okay, there's a secant line, and I want to know what's happening at this second point up here. I'm going to move that, and I'm going to move this red point back toward that, and you can see a tangent line right in here as well. Okay, so when this is right with that, there's a tangent line at that exact instance. So the slope of the secant is 2 points anywhere on the curve, the slope of that line, but the slope of the tangent is at this one specific point. So if I move these 2 points closer to each other, that is, the distance between those 2 points becomes 0, okay, then I'm going to get a tangent line at that point, which is the instantaneous rate of change at that point. Now, when we do this, we can do it algebraically with a limit. The limit as h, the distance between the 2 points, goes to 0. The function value at the second x minus the function value at the first x divided by the difference between x plus h and x. Look, x plus h minus x would be, that would be x2 minus x1. Well, that's just going to be h, so in our denominator we just put an h. So what we're doing when we do this limit is we've got a curve or some kind of a function, and we're going to find the slope right here at this exact point. It's only touching that line in one place. That concept is called the derivative. Now, as we move forward, you'll find that there are some shortcut ways to find the derivative, but in the beginning, we want to find the derivative by looking at this limit. So let's try one. If our function, f of x, is x squared plus 2x, and I want to find the limit as h approaches 0 of f of x plus h minus f of x divided by h. The first thing I have to do is I have to find f of x plus h. So instead of the x's in this function, I'm going to substitute x plus h squared plus 2 times x plus h. So I've substituted the expression x plus h in for x. All right, so that's going to give me x squared plus xh plus xh plus h squared. Where did I get that? Well, I'm doing the full rule of x plus h squared. It's not just x squared plus h squared, it's x squared, xh, xh, h squared. Okay? And then this is going to be plus 2x plus 2h, and that gives me x squared plus 2xh plus h squared plus 2x plus 2h. Now, I don't have any like terms I can combine, so I'm done with that part. Now, look at the second part of the formula. It says from this, we're going to subtract the original function. So I've got to subtract an x squared, and I've got to subtract a 2x. So I'm basically taking the opposite, look, the opposite of every term in f of x, and then I'm going to combine it with the f of x plus h, and so the x squares cancel out and the 2x's cancel out, and I have 2xh plus h squared plus 2h. Now the last part of the formula says we have to divide that new expression by h. So I have to divide not just the first one, but all of these by h. So I'll divide all of these by h, and I will get 2x plus h plus 2. So I've got the limit as h goes to 0 of 2x plus h plus 2. Now there's no denominator, so I can just substitute the value for h is 0, and that's going to be 2x plus 0 plus 2. So the instantaneous rate of change for the function x squared plus 2x is this formula. Look, this is the slope of the tangent, and it's a formula that will tell us anywhere on that curve what the slope of its tangent is. Remember, we could be anywhere on the curve, and if we plug in that x value down here, we can find out what the slope of that tangent line would be right there at that point. Now, sometimes they ask us to go a little bit farther, and they ask us to find the equation of the tangent line to the curve f of x equals x squared plus 2x at the point where x equals 5. So you've got a function, looks something like this, okay, and we want to know what the slope of the tangent is over here at 5. So look, here's our tangent lines like this. Can't really draw it very well, but you get the idea. It's just touching that curve just barely at one point. So we know the formula for the slope of the tangent. We got it to be 2x plus 2. So the slope at 5 is 2 times 5 plus 2, which is 10 plus 2, which is 12. So the slope here is 12. That means we rise 12 and we run 1 to get on that line. What's the equation of that line? Well, the equation of a line has a slope and a y-intercept. Okay, y equals mx plus b. So we have to have an xy point, and we know that x is 5, so we have to find the y when x is 5. So f of 5 is 5 squared plus 2 times 5. That's 25 plus 10 is 35. So our point is 5, 35. And our slope is 12. So we're going to use this formula. We're going to plug in the y. 35 is the slope, 12, times the x5, plus some b value that we can now find. 35 is 60 plus b. Subtract 60. Negative 25 is our b value. So our equation is y equals 12x, that's the mx, and our b is negative 25, so minus 25. So that would be the equation of the tangent to this curve, x squared plus 2x, when x is 5. Y equals 12x minus 25.